So when I'm doing a machine learning project, I really like that first bit where you're doing all the exploratory data analysis and you're making models and you're training things and you're testing it and you're in this fun loop of trying to make a really great model. But sometimes when you're doing that, you can sometimes catch yourself and be like, oh, my notebook's called like Untitled Final. I should probably fix that. Or your colleague comes up to you and asks, hey, can I try run this on my laptop? And you're just like, good luck, because there's no way that environment's running anywhere else. Or someone comes up to you and like, oh, this model's great, but how are we actually going to use it? How are we actually going to get this thing from your laptop and into production? And you're like, oh, that's actually also a really good question. So you go to Google and you type in something like DevOps, but for machine learning, and you see a link from Microsoft, and you're like, oh, thank God, I'm saved. And you go into Microsoft link, and you're still feeling hopeful at this point, and you scroll down, and you see something like this. And you're like, just what the fuck's that? Like, no bit, I actually don't know. It's all these like boxes, this not explained, all these arrows going random places, all these colors, but there's nothing down there telling what any of it means. And you think, yeah, this is definitely a production-ready solution, but maybe for now, I'll ignore that and I'll just make a new notebook called Untitled Final, Definitely Final. So this is my talk, MLOps and ML-Flops, and it's about, well, me kind of trying to understand what these diagrams actually mean. I just, through my time doing data science work and trying to make good models, I realized that there's so much assumed knowledge when you try to deploy something. And there's lots of reasons for that we can get into. So this talk, it's not about the precise code you'll write to deploy something, and it's not about an exact thing. It's trying to unpick how these models are drawn and the architectures are drawn. So I'm Andrew Blance, and someone laughed because I put doctor there once. I was like, you gotta do it whenever you can, whenever you can. I work at a company called Watersons. We are a broad tech consultancy. There is a cybersecurity bit and a managed services bit and a bespoke software development bit. I sit within the data team who do lots of really cool Databricks and Azure and Microsoft platform type deployments and implementations. And I also work in the sort of innovation area as well. So stuff like, can we use a robot dog to go into greenhouses and detect air pollution? Or can we use sensors to stop black mold growing in houses? Or can we use virtual production stages to help architects draw all the plans? Outside of my work, in my real life, I host, and I have to say this every time I get on stage, I host a really great comedy podcast called Brains on the Outside. So if you have one takeaway from this session is please subscribe to my podcast. I really need that for my ego. I may come up with stupid business ideas every week. Aside of that as well, I also co-run the Northeast Databricks meetup. We meet every 2 months and we talk about Databricks. This is our second one coming up on April 20th. And Holly Smith will be there talking about how a table ruined her life. That's her exact words, not mine. So this talk is going to cover some MLOps, some ML-Flops, and the architectures to deploy models. Now, when I was writing this, when I wrote the abstract, it was very much that description. But about a week ago, I had this crisis, and I was like, but how can I make MLOps fun? How can I make it exciting? And I thought, what if I just did the whole thing as a game show? And I made you all take part. Luke, you don't not make eye contact with me. It's a surefire way to be called up on stage. So I scrapped that, thankfully, but a little bit still that lives to section 2. MLOps is an interesting bit because it's quite a young and emerging idea. We know that training a machine learning model and putting it in production has its own requirements for DevOps, which sort of necessitates a whole new word for it. But how that works and how that will precisely happen in reality is still kind of up for debate. So I'm willing to take constructive criticism a little bit. This is my, it's called MLOps and ML-Flops. So I thought, in good faith, I should put some ML-Flops in here. This is, albeit it's very clear, before I worked at Waterstones for some job security. This isn't anything to do with my work. This is my laptop when I did my PhD, and I searched Untitled ipynb, which is like it's just an untitled file that you some code in, and this is all the results I found. It's pretty bad. It's definitely ML-Flop. But there's actually a lot of reasons why that is, not just from me being lazy. Like, what's in these files? Are they backed up? Like, if I wanted to give to somebody, would it run? If I need to go back and find some code I've written, I would have no idea where it was. That file there is in a folder called data, which, how's that going to help anybody? So you can't live like this, guys. You can't do it. So we need to go on a very big journey and get out of there and develop a versionable, deployable, and responsible machine learning deployment method. And though that is true of every coding project we undertake and every deployment we might do, have it versionable and deployable, the thing that kind of makes MLOps different is this need to be able to retrain it and monitor how it's performing out in the real world. Machine learning projects have different properties associated with them. When you deploy a website, it's kind of just a function of the code that's written it. After it's out there in the wild, in some sense, it's done. It's almost a static thing. In some data projects, well, now it's a code you've written and the data you have. But in a machine learning project, it's the code you've written and the data you have, but also the model that you have trained. All these things you need to keep a track of. Like, if your goal is to figure out what was I doing in this notebook 3 weeks ago, you need to know more than just your code. You need to know what was the state of the data and what was the actual model I'd created. There's also lots of things on top of that as well, more subtleties about data drift we'll get into later. This is, does anyone know what this is? Do you want to answer it, George? It's a, yeah, I mean, they're usually drawn as curves to be a data maturity curve, but as George said, this is a data maturity quadrilateral. Consultants love throwing these things out, and it's a nice way of sort of framing where people are with making data projects, either a project itself or a company-wide. So right down here is absolutely nothing. So this is maybe you're all passing papers around your factory. Very little data governance in place. And then you can move up that slope here into ad hoc analysis. So maybe you're using Excel to analyze things in one-off pieces. Then you go to BI, so you can use Power BI, maybe a more structured, organized way. Maybe there's now a single source of truth. Lots of jargon like that to analyze data. And then you get into the really buzzwordy, exciting, where everyone wants to be, doing predictive analysis on your data. You have this great base now, hopefully, that you've built, which is really clean data set. And you want to be able to predict the future off that now. And then once you can do that, and people believe it, the next step is being data-driven and making decisions off of that. What can happen, though, is people are down here, and then they go to a conference, or they read an industry trade magazine, and it says all your competitors are using AI and machine learning. And you're really far behind now, actually, and your business kind of sucks. So they go out and they hire a whole bunch of PhD students, and they put them in a corner somewhere, and they go, just do some AI, thinking that they'll be right up there now. But what can happen is that they make a really great model on their laptop, but their laptop also has 200 other files called Untitled ipynb, and it can't run on anyone else's laptop, and no one's quite sure how they're going to scale it. So that's kind of not just why you need to eat your vegetables before you have your main course or your pudding. It's not so much also about why you shouldn't skip that curve. There's another bit of where are you in this MLOps maturity curve. I love scales and curves and little balances between things, so I put another one in here. This isn't my invention, this is Microsoft's. And right down here, you have no MLOps. You're me in 2019 when you have 200 untitled notebooks and you really, really hope to God you don't forget where you saved that last one because you're never getting it back. Then you move up into DevOps, which is traditional DevOps standards. You're version controlling things. You have a GitHub or an Azure DevOps platform to save things and call it back. but you're not really maybe looking so much at monitoring models or anything like that. You just have maybe a standard solution. Then we go further and further up. Our goal is to have a way to automatically monitor and train things. So we start getting this idea of automatic training. Your models can be automatically retrained. You don't have to go and manually rerun the code. Stuff like Azure DevOps and GitHub Actions have ways to make pipelines that can automatically run, that can pull code into them and retrain models. So here we're getting to this automation of things. And then you can go a step further into automatic deploys. So if your model can be tested that you've just trained and it's good enough, it can be pushed into production automatically. And then right at the top, we have full MLOps. So this idea that we are actually training a model, it's going through testing, it's in production, and if we decide it's going wrong, we can retrain it. How many people here are data scientists or machine learning engineers? Me too. How many people here really feel that they're right at the end of that scale, where they're just nailing it? Yeah, me neither, so it's okay. So it's kind of a scary journey, right? It's a big thing and it's really difficult, but you have to do it. Like, you have to put this work in. There was a project I was on semi-recently where I was doing some predictions on things, and I got some really good numbers out, and they were like really great. I was like, shit, I've done it, I've cracked it. So I went and told everyone these numbers, and everyone was like, oh shit, Andy, you've really done it this time, well done. And then I came back after the weekend, and now the numbers were actually really bad. And I had to go back and be like, actually the numbers are bad now. And I realized, well, this is a really good lesson I've learned in being able to back things up and being able to go back and really understand not just the serial code now and the model you have now, but what was your model like a week ago? So if you have a really good reason of doing this, why don't we do it? Why isn't that for the record, everybody who says they may do data science here didn't put their hand up about being right at the end of that curve. So why don't we? Well, it's actually all really difficult. It's really difficult to put that diagram into production that we saw at the start. It's really difficult to actually make all this stuff and retrain it and have a good use case. It's also difficult because when we learn about, well, I feel personally, when you learn about data science and machine learning, you're taught this fun bit. You're taught the exciting bit at the end, which is making predictions, and there's all this other stuff that you really need to know. It's engineering stuff at the front that can be kind of dropped off a bit. And another reason is that it's a little bit boring. And by this, I don't mean that MLOps is boring. I mean, it's this thing of when you read a news article on Twitter, or The Guardian or Wired, it's not about a cool new MLOps deployment. It's about how ChatGPT is going to change the world. So I think people tend to gravitate towards that when they're learning about it, and this MLOps frameworks kind of fall off. And again, if you don't do, there's nothing you see that, so you get your PhD students and they're building something, and it might be a really cool proof of concept, but how much is that model worth, really, if you can't actually use it? It's not really worth that much, I don't think. So you can pour all this money into making things, but you have to have a route into making it real. So here we are in my game source section, which doesn't really exist anymore. I feel we've created a safe space here, guys, right? I've told you some of my failures in life. It looks someone making eye contact with me. Would anyone like to share one of their ML-Flops? This again isn't actually accurate to things I've done, but these are examples I thought. Yeah, there you go.
Sure. So the biggest ML-Flop I had was our deployed model was people emailing me a CSV, run the CSV through the code, and email them out the predictions.
That's really terrible. Can anyone beat Alex over here? I'd be a really good teacher, because I can sit here and stew in the awkward silence much, much longer than you can. You've won, Alex.
Is there a prize?
So we have this problem, which is we need to deploy a model. And we have this other problem, which is when you Google how do you deploy a model, you get these really, really obscure and difficult to read diagrams. So what we're going to go through now is right from the basics of basic DevOps, storing data and building it right up to a point where we can deploy a model. Our DevOps solution needs to handle challenges that are unique to machine learning. So the ability to version your model and the ability to track your model in production and the ability to track the data going into it to make sure it looks familiar to the model. And I'll explain exactly what I mean by that later. So right at the ground floor, we have this idea of just standard DevOps. So continuous deployments, continuous integrations, version controlling of your data, and just security, like so you won't get hacked and destroyed and your life ruined. Does anybody know what this is? Who said that? Oh, what's your? I'm really sorry. I don't have another duck to give you. Well, actually, I do have one, but that one is actually mine. See, it's a positive reinforcement that gets people talking at conferences, I think. Thank you. Yeah, so this is a data lakehouse, and this is maybe our default solution for cloud deployments. You've probably seen them, you've potentially seen them around this week. They're quite a popular and modern way of storing data and transforming it. So here on the left, we have all our sources going in. This is the actual files. This is the CSV files that people are sending Alex. And instead of him crunching them by hand, we are going to drag them out from wherever they live and dump them into storage in Azure. And they get landed in this bronze layer where they're pretty raw and yucky. And we can go through this medallion architecture, it's called. So from bronze to silver to gold. And as they go through this process into different storage parts, the data is getting cleaned up and ready for analysis in Power BI in the end, right over there. So in silver, we might do things like getting human readable names of columns. And then as it goes into gold, we might do some aggregations and really clean everything up. This is all underpinned by, I always get Delta and Parquet mixed up, but it is Delta. File format, which allows really fast reads, and that is run using Databricks as a computational engine here. That's doing the crunching, and all the compute and the VMs are stored up there. And when it gets down to gold, it can then be pushed through and read with Synapse, and then Power BI at the end there as a self-service tool, and you can make pretty diagrams and everything. All this lives within Azure, which is secure, and we can version control it, and we can do all the nice things that we assume we can do in the cloud, but being able to scale servers and everything like that. So we have this nice home for all our data, but there's this next layer we can add on top of that, which is the repeatability of this process, and that comes out in a few ways. This diagram here has actually a lot of moving parts. It's drawn quite simply, but well, simple to an extent, but we already have a lot of symbols there, things that we're going to need to create, resources in Azure that we'll need to make ourselves. And we're going to want to be able to make them the same every single time. And there's actually a lot of other stuff hidden in there that I haven't drawn. So all your securities and things like Key Vault to keep your secrets in, endpoints and VNets and all sorts of other structures that we will need to make this a solution that we can actually give somebody. We also need to be repeatable because the next time you make it, if you've made one and it's perfect and all the security things line up and work, you don't want to make it again and do it wrong, make a little mistake. There's also the thing of this process there's a lot of steps to make that. It's to do run for dev, UAT, and production environments, it's over 100 steps to make that whole thing. So that setup time, we can greatly reduce that by looking into doing infrastructure as code. So the idea we could codify that whole structure and just run what's called Terraform, which can create these resources in Azure. So instead of having to hand create it, it takes a week, we can make a little script that'll do it in hours, which has lots of obvious huge benefits. So we're going to pivoting now into the machine learning stuff a little bit, as we can talk about what sort of things that we could terraform into existence on top of our data lake to help us do machine learning. So here we have Azure Machine Learning, a very literally named product from Azure, which you could, I'm sure, guess what it does. It is Microsoft's machine learning platform. So in here, you can get compute and VM to run experiments on. You can write code in notebooks. You can save models out to it. So you've trained a model you like, and you can save it here as a version of your model. You can do loose data versioning with this, more like this is version 1.1 of my data, version 1.2. It's not as in-depth as like feature store or anything like that, if you know what that is. But there is a way of saving versions of data out very roughly. It's not great. We also, so that is where we would run a machine learning project potentially. You can also track experiments. So if you're doing hyperparameter searches, you can save that all off there. The idea is this is a pretty great tool of being able to say, I trained this model on this day, and what was it like? It's also, if you've seen, there's a few talks this last few days. Gavi's talk on AutoML and cognitive services, that's also built into Azure Machine Learning. So you could run your AutoML programs through Azure Machine Learning. Then there's also Key Vault, which is a security thing for storing secrets. So you don't have to write secrets in your code. You can store them in Key Vault. App Insights, it's all very literally named. This is going to provide insights onto the actual infrastructure. How many times the API being called? What sort of, like, is it going to crumble? Is it safe? Do we like it? Then we also need to create storage. And there's also this other layer, which I'm not really an expert on, but I'll mention it because for a fuller picture. But having VNets and private endpoints as well, so our solutions are really secure. I can talk to other places that are really secure. So the point here is, yeah, we want to do some machine learning, and there is a route which is I just fire up Jupyter notebooks on my personal laptop. But there's actually a lot of other things hidden in the background to get this project up and running. A lot of security things and watching it and storage and choosing the right platform to write it on. Aside from Terraform being really good at just allowing us to repeat this process of creating environments and structures, it's useful as well because we're going to have to do it multiple times. We don't just want one environment to make our model in. We're going to want a separate set of resources for users to do testing in. And we want another set of resources, which is our production place, where we can feed this model to the app or the internal service or the public or wherever it's going to go. We can then use pipelines and the DevOps platform we use to push code between these environments. So we don't have to do lots of copy pasting. This is where Terraform is really great, so you don't have to make it over and over again. At this stage, do people have any thoughts or feelings, any questions?
On Terraform, do you use it to continually update dev and deploy to your own team? Does it have a state file, isn't it? Where you just build it all once and forget about Terraform after that?
There is. Oh, the question was if I'll repeat it. If I'm wrong, shout at me. When we use Terraform, do we use Terraform as well to do the deployments and pushing things through these different environments, or are we just using it to create the environments? Is that your question?
Yeah, effectively. So you're not using it to continually update your own changes?
My understanding of it is we just use it to create these environments. When I've created things with Terraform, it's just I create it and then I'll like push the code through with like pipelines and things like that. But I can find other people who know way more than me to answer your question later on. So I've kind of hinted that there's lots of differences between machine learning projects and normal projects, and we're going to kind of go in a bit more detail about what I mean there. So when you train your model, so your machine learning model is only as good as data going into it. It can only effectively know things it has seen already. So when you train it, that's great. But then 6 months later, maybe the data you're feeding into it in real life and production has become different. Maybe when you trained it, you were training on a data set of cars and there was 50% forwards and 50% voxels, and that was great. But now, in the real world, it's not like that anymore. It's shifted. The data set has drifted effectively. Maybe there's 60% forwards and 40% voxels. Maybe there's an entirely new type of car you care about. Or what these cars look like is now different. Maybe the shape of a forward is very, very different to the shape that you trained it on. And this is what's called drift. The data that is in the real world now doesn't really match. It doesn't link up to the data you trained it on. So we need to be aware of this when it hits production. There's also the idea of model drift. So what it's predicting, maybe it used to be predicting 10% cats and 90% dogs, but now it's not that. Now it's predicting 50% cats and 50% dogs. These are kind of interesting concepts and useful to think about because when you test a model on your laptop, you know the prediction of the model and you know what the true answer should be. So you can compare and actually say, hey, my model is 90% accurate because you know the truth when you train it. However, out in the real world, you won't know the truth. So you have to find proxies to try and understand, find ways around to understand, is my model actually performing well? Because unless you can go to the users of your model and ask them, hey, was that output correct? It'll be very hard for you to know. So these are sort of proxies effectively to understand, is my model, am I confident my model is still working correctly? So we also need to be able to then, if we don't think it's behaving correctly, the outputs are all different now, the data going into it is very different now, we need to be able to go back and retrain it, hopefully without downtime, to update it and make the model better and represent reality again, rather than this reality maybe from a year ago that was a bit different. We also need to be able to version these things. As I mentioned, your machine learning model, it's a function of the code that wrote it, the data that was trained on and has gone through it, but also the model itself. And we need to be able to link those things together and say, hey, what was I doing last Tuesday? What was the state of all this? So we're going to try and build now a solution to do that. So this is kind of heavily inspired by a really useful, if not a little complicated to use tool, which is Azure's MLOps accelerator framework, which is a really great place to start if you want to dive right into this. It's a way of creating infrastructures. So this is kind of inspired by that. So we saw the lake house, and it has the bronze layer, the silver layer, and the gold layer. What we're going to do is pull all our data for our training of our model and all our data analysis from the silver layer of our lakehouse. So we're pulling from the silver layer, and we're in this dev environment that we have terraformed into existence that's secure and nice and all the good stuff we want in it. And inside there is Azure Machine Learning. And in that instance of Azure Machine Learning, we're going to go in this loop of doing data analysis and feature engineering, training our model, testing it, doing our hyperparameter searches, and all that stuff that's fun and we like to do. And we're going to do this loop over and over again until we're really happy with the model we've created. And we can be saving these models and version them effectively inside Azure Machine Learning so we can get back to previous versions. And we can save all our code inside DevOps so we can do that. And we can use, well, there's this slight data versioning feature in Azure Machine Learning. I think there's more coming out soon. And there's sort of third-party open source tools as well we can use. Sort of try to version the data. We then can, once we're happy with this, we now want to move this data and the model somewhere else, where we can do more testing to it, potentially give it to our users to do some testing to, so we can set up our DevOps pipelines to pull this code out and put it somewhere else. And where that's going to go is our UAT environment, our user testing ground. This is a separate environment, a clean set of resources that we've also created with Terraform, hopefully, with a version of Azure Machine Learning inside as well. And in there, this area is not focused on this development cycle. This is focused on unit testing and checking out our model works and doing responsible AI tests to see is our model biased or anything like that. Inside here as well, there'll be functionality to actually containerize and open an endpoint to our model so users can access it and send it, whatever language problems or vision problems or just data they need to send it to get results back. So maybe, our users or us, anybody, we're testing our model, we're finding out, is it good or not? And at the same time, we can now think about monitoring it. App insights can be pointed at this version of Azure Machine Learning to sort of monitor infrastructure performance. And we can write other code and the features of Azure Machine Learning itself to monitor things like model drift, so the outputs of the model in production, data drift, how are the inputs to the model looking, and how do they compare to what we trained and tested it on, and general sort of model performance, how fast is it responding. Now, this can then be linked back. It could trigger a DevOps pipeline at this point to try and retrain our model. If the monitoring was saying, hey, actually, the data we were looking at now is really different to the data from 6 months ago, maybe we should think about retraining. It could email the user and be like, hey, try and retrain and start the cycle again. Or it could try and push that automatically, depending how much you trust everything. The final, well, an option for the final bit here is having a third environment now, which is our production environment, which will be terraformed into existence, and it'll be a clean place that's not linked to these other two places. And here there'll be a version of Azure Machine Learning, and this version is just simply to push the model out to the actual user of it, the actual production case. And that link between UAT and prod can be governed by a pipeline as well, which when the results in UAT look good enough, it'll trigger this pipeline and either manually or automatically to push it into production. Having this split is really good. You don't want to be messing around in your development environment and affecting something in production. Maybe you'll want different security standards in different places. Maybe you'll want to link to different data sources that'll require different standards of security. So it's good to split this all out. So we've taken something which was 20, 30, 40 Untitled notebooks on your laptop and tried to turn it into something that's really repeatable and version controlled and secure, and that can be tested and trained and given to our user. And this all sounds really great. This is what we wanted. But there's also the way of looking at this and going, well, this is way too much work. This is a lot, How am I going to handle this? Originally, the slide was, fuck it, this is way too much work. But then I realized the slides are all shown on the big wall outside. I kind of thought about the optics of having this profanity-laced slide just out there for minutes in the end. I thought, I'll tone it down. But you get the idea. It's a lot of work. And this wasn't built in a day, People in our team spent ages and ages and ages getting that lakehouse solution so good. And even this MLOps solution is kind of new for us, and we've worked with the MLOps frameworks Microsoft has, but it is difficult, and it's a lot of work getting it running correctly. But it's better than this, So you can ask, well, where should we start? What's the first step I should take? Right now, I am on my laptop, and I don't have it in GitHub. And it's not going to run anyone else's laptop. Well, the first thing there is get it on GitHub and try develop things in Azure Machine Learning. You have the option there, at least then, to scale out to something that will be production ready one day. And you have a lot of benefits of being in Azure where you can hypothetically plug into data sources you have already, and you have lots of security that's built in. It'd be easier to share it with your friends and colleagues, whatever you make. But 3 more concrete things, which isn't just go on Azure, which makes me sound like a salesman. I'm not, and this thing isn't helping the salesman vibe, is these 3 things I kind of thought of off the top of my head, which was standardization, and I mean this in a few ways. Budgeting, which is fairly self-explanatory, and coding practices itself. So with standardization, here I mean one option is when you are in Azure and you're creating your resources to run this project, you're going to end up spinning up loads and loads and loads and loads and loads of things probably if you want to have a secure environment. Little things like just having a standard naming convention is a good idea. This makes it easier if you want to create a new project and then other people developing on it will have some frame of reference of, oh, this is what projects look like. It also drills down a bit deeper into the actual directory structure itself of having some standard layout of that. There's lots of good things like cookie cutter data science and cookie cutter software and engineering and development packages that can create you very standardized structures so each project looks the same as well. And then there's even deeper, which is the code itself, like where it's your standards for naming conventions and things like that. Python is a really exciting language, and I really like Python, and it has lots of really great linters and things like that. There's a really great feature called MyPy, which basically turns Python into a strongly typed language, which is fun and horrifying in different ways. The next thing is about budgeting. This is a big continuing ML-Flop in my life. Every month I try so hard to budget my Azure resources, and every month Microsoft has the audacity to email me to say I spent too much money. Like, they cut me off. And every month I have to email me like, no, I didn't actually. And every month they email back saying, yes, you did. And every month my expenses are all messed up because I'm spending Microsoft money and they're sending me money. So I really cannot emphasize enough how great it is to budget things. This is a feature inside Azure, which is tied to resource groups. So this is a resource group, if you're unaware, is kind of the home for all your resources for a project. I remember when I started using Azure, I had one resource group, and I put every single thing I did into that resource group, which is very bad practice. You should have a resource group for basically everything you do, every project, the dev part of it, the UAT part, and the prod part. And a big benefit of doing it like that, apart from just being neat and tidy, is also you can then track the costs of each part. The third thing I kind of talked about, which I think is an underrated aspect of doing DevOps and MLOps, is actual coding standards. And I found this as a project in my PhD where I won't make you count, but there's about 15 notebooks there that all do basically the same thing with only very tiny minor differences. So this is kind of a bad thing to do because you could have like one big class you pull from. But I feel it's just like learning not to have spaghetti saves you so much time when you try and push things through. I've seen people like, I think it's really exciting actually when I see things like this. People, there's an example of someone using lots and lots and lots and lots of if-else statements, like hundreds and hundreds of lines of it. Like, it was obscene. Hundreds of lines of if-else statements. And then you could see at about line 2000, this guy had obviously read the tutorial on for loops. And all of a sudden, it was just for loops after that. And I was like, that's really exciting to see, but also a bit scary. And that journey never ends of learning new things that can clean up your code. And as you try and push things through out of dev and into UAT and into production, and you want other people to be able to reuse it, it's important to try and understand how to write Python. And in a scale of what does a good function look like, but also the scale of what does a good project look like. So that's kind of my basic suggestions for a starting point. There is this book by Chip Hewen, which is Designing Machine Learning Systems, which is really great. A really good sort of introduction and intermediate and expert level thing. There's Fluent Python, which is the best coding book I've read, which isn't about the game Doom and isn't about 6502 assembly programming. It's really clearly, it's an intermediate an above level book, very clearly and concisely going through how do you write a good class, how do you write a good function, how to use operators and async and all these other features of Python you might not know about. And I can remember trying to learn about classes in university, and they're like, a class is like a car and a function is like a wheel. And I was like, what are you talking about? But Fluent Python is way better than that. So that's why I really recommend that. There's this Kuka data science package, which I mentioned earlier, which is about dropping down directory structures, and then also this MLOps accelerator framework, which is code to get you started trying to deploy the structures that I was showing you today. It's still a big work in progress, and it's not, as with lots of things that Microsoft show you on their website, it's not this really clean and nice and easy thing to use. It's actually quite difficult, I found, but it's a really great start, a good inspiration how to do it. This is my feedback form. Please leave me feedback, but only if it's nice. Okay? That was a joke, but yeah. Yeah, so that's it. We've sort of started at the stage where we had 100 notebooks, and we've kind of built up this idea of what does good data storage solutions look like, what about deployments, and we built this MLOps framework to try and tackle things like data drift. So yeah, hopefully your next MLOps deployment won't be an MLflop. It's like, oh, I laughed though, so it was good. Yeah, that's it. I am very, very aware that I am the person standing between you and the party tonight. Okay, so yeah, I'll take any questions from the floor. I'll also take them at the pub as well. But yeah, go on.
What kind of things do you do with unit testing in the UAT environment?
I guess there's like lots of standard things, lots of code checks you could hypothetically do. Actually writing unit tests is a great start, which I'm very bad at. It's always nice to start a project and think, I'm going to do it with unit tests this time, and then you just don't. But because those things can be automatically checked in these pipelines, as either when you push to GitHub or push it through things. So like MyPy, for instance, but making sure Python is typed, that can be flagged within your CI/CD pipeline, which is a really great way of just standardizing your code and linting and actually just checking quality of code.
So with your data lakehouse being built on Databricks, do you see there being a benefit to doing kind of your ML workloads?
Oh, yeah, definitely.
Particularly with MLflow being a native Databricks.
So as I kind of alluded to at the start, there's no right way of doing this, and it's kind of new. How do you design these sort of systems? I totally agree. Databricks might actually be the better way of doing it. If you have all your engineers working in Databricks to begin with, it kind of makes sense just to run everything in Databricks and create a similar structure to that. There was a talk, it might have been Gavi's also ML talk. I'm not sure if were you there? Did you see that one? Possibly. It showed all these really cool features of AutoML, where in AutoML, if you train a model and save it to AutoML, there's just little toggles that push it to staging and production. I think you're totally right. It's also just nice. Me and James behind you, we worked on a project where, because Databricks is so versatile and so easy to work together, people can like write in the languages they like and the styles they like, and it's very easy for collaboration, I find as well. And you have all the huge benefits of just the performance of Databricks. I think is maybe more performant than Azure Machine Learning, I think. I'm taking the silence as a good sign, just stunned. Holy crap, that was so good. 10 out of 10 on this feedback form.
I think 9 is the max.
9. Ah, shit, okay. I embarrassed myself. Thank you very much for coming. That's all I have, really, for you. Oh, what is it, George? I know George, I could talk to him in that tone. I wouldn't talk to the rest of you in that tone. What is it, George?
When's the next episode of Brains on the Outside?
That's an excellent question. Brains on the Outside, the universe's best comedy business idea podcast, comes out once a week, so on Monday morning. And we discuss fantastic business ideas, like what if there was a holiday destination, right? Where you just go there with your friends and there'd be a big field and they'd rent you like diggers and stuff like that, and you could dig a really big hole. I like it. And yeah, thank you, yeah. So please subscribe and like, etc.